Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. So we know that the layer 2 of the OSI model deals with MAC addresses, and that's great for small networks, but for all these devices that are on the internet, we need a robust logical addressing method that acts more similar to addressing like the post office uses. This also lets us break down large networks into smaller networks, which are called subnets. Now let's move up the OSI model to layer 3, the network layer. Layer 3 is the network layer, and instead of frames like we have at layer 2, our PDU is called a packet, which is created and addressed so it can be sent between networks. You might have heard of an IP address before, and that's the logical address that gets assigned to a system. If you're wondering what IP stands for, it stands for Internet Protocol, which is a major networking protocol that we use today, with the other one being the Transmission Control Protocol. We typically refer to it as TCP/IP. If you're interested in how all this TCP/IP stuff started, it actually came out of the agency called DARPA from the US government in the 1970s. So now we have a MAC address at layer 2 for traffic on the same network, and an IP address at layer 3 for traffic on different networks. Keep in mind that the MAC address is burned in, and we don't change that. However, the MAC address could be changed and reassigned, but we can't have two systems with the same IP address at the same time. Also, IP addresses don't just magically appear, and they either have to be manually assigned by an administrator or assigned from a protocol like DHCP. IP addresses are written in dotted decimal notation with 4 8-bit numbers that range from 0 to 255, which actually means that we have 256 numbers because we're starting at 0. Routers are network devices that connect subnets together, and they use IP addresses to forward data. This allows routers to be flexible and not forced into using Ethernet between devices if you so choose. I want you to think about your home router that you use to connect to the internet right now. You might be starting to realize that yours might have switching and routing capabilities inside of it. And that's definitely true. However, when you're on an enterprise environment, you're going to have dedicated routers and switches that are much larger than what you have at your house. When talking about TCP/IP networks and sending data, there are 2 containers the data must be wrapped in. A frame, and that lets data move from one device to another. Inside of that frame is an IP-specific container for routers to determine where to send that data, and that part is considered the packet. When we're talking about the packet, this is basically a high level of what it looks like on the screen here. Remember our encapsulation definition? When data is being sent, the packet is created at layer 3, then it would hand it to layer 2, who would put it into a frame by encapsulating it. This is what a packet inside a frame really looks like. When a router receives the data, it's going to strip off that frame, leaving the packet, and see which IP address the data needs to go to, and then it's going to create a new frame to get the data closer to that destination and send it on its way. When the packet finally gets to the NIC of the destination system, the frame is still going to be stripped, and then it's handed off to the rest of the OSI model to let the remaining layers continue doing their jobs, whether it's a file, email, and so on.